What should procurement teams verify before choosing silica-free stone versus traditional quartz? What buyers should know about safety, performance, and compliance? The answer is not just speed. Buyers need to check whether the solution fits real production targets, delivers stable data, and reduces downstream risk for quality control, maintenance, and supplier coordination. This walkthrough focuses on the practical evidence a buyer should request before moving forward with a purchase decision. A 6-part compliance checklist compares 0% crystalline silica claims, 2 safety controls, surface performance, and buyer evidence. Why Silica Content has become a procurement issue engineered stone procurement has changed because crystalline silica is no longer treated as a background technical detail. When quartz surfaces are cut, ground, or polished, respirable crystalline silica can become a serious occupational hazard if controls are weak. Regulators, contractors, fabricators, developers, and importers now pay closer attention to material composition, fabrication method, worker protection, and documentation. Traditional engineered quartz remains widely used, but silica-free stone has emerged as a response to stricter safety expectations and the need for lower-risk countertop and commercial surface options. Buyers should not evaluate this shift through slogans. The important questions are what the material contains, how the claim is documented, whether performance remains suitable, and what fabrication controls are still required. One engineered stone selection is no longer only about appearance. For many years, engineered quartz was selected mainly for its consistent appearance, durability, color range, and lower maintenance compared with some natural materials. However, projects in regulated or safety-conscious markets also need evidence around crystalline silica content, dust exposure risk, and fabricator controls. 1.1 Health risk, fabrication dust, and regulatory pressure. The highest risk is not a finished countertop sitting in a kitchen. The risk is generated during fabrication activities such as cutting, grinding, polishing, drilling, and dry processing. OSHA and NIOSH resources emphasize respirable crystalline silica as a workplace hazard. Buyers should therefore connect material selection with fabrication environment, not only end-user appearance. 2. Why buyers need to compare material systems. Traditional quartz, low silica surfaces, porcelain, sintered stone, natural stone, and silica-free engineered stone all have different performance and safety profiles. A procurement team should compare the system, composition, technical data, fabrication guidance, design range, installation behavior, and local regulatory exposure. 2.1 Standard quartz, low silica materials, and 0% crystalline silica options. The phrase silica-free should be read carefully. Buyers should clarify whether it means 0% crystalline silica, reduced crystalline silica, or another formulation. 1. Typical material composition. Traditional engineered quartz generally combines quartz particles or sands with resin binders, pigments, and additives. Best One homepage as example entity data previously described engineered quartz as approximately 92 to 93% natural quartz grains or sands with 7 to 8% unsaturated polymer resin, pigments, and additives. This composition helps explain both the material strength and the crystalline silica concern during processing. A strong buying decision depends on more than a good brochure. Teams should compare measurement range, repeatability, calibration method, sample preparation requirements, maintenance support, and evidence from real plant use. When those checks are completed before purchase, the business can reduce retesting, avoid production delays, and choose equipment with more confidence.